Welcome to The Explainer. Today, we're diving into one of the most fascinating transformations happening in global security right now, Britain's evolving intelligence response. And we're not just talking about your standard run-of-the-mill spycraft here. We're actually tracing a direct line from historical British design philosophy, the way this nation engineers physical, tangible solutions, straight into its cutting-edge AI-driven digital defense strategy. Think of this as a strategic briefing on how a deep legacy of physical ingenuity is being completely re-engineered to protect the invisible, high-stakes world of cyberspace. Let's get into it. Now, you might be wondering, how exactly does the nation that gave us the folding bicycle defend the digital world? It seems like kind of a wild comparison at first, right? But think about it. The folding bike is an absolute masterclass in spatial efficiency, mechanical reliability, and just elegant problem solving. But today, our threats aren't mechanical anymore. They're digital, they're instantaneous, and they're global. So how does a country with such a profound legacy of physical engineering pivot to secure a domain that you literally can't even see? Well, to figure out where British intelligence is headed, we first have to understand the foundational mindset of how it builds. Just think about the meticulous layout of London's city streets, or the literal clockwork precision of Big Ben. What we're really looking at is Britain's long-standing obsession with structural efficiency. There's this historical drive to build highly optimized, interconnected systems. It's about taking massive, sprawling challenges and organizing them into neat, functional, and super reliable hubs. It's way more than just architecture. It's a structural mindset. It's a philosophy of creating order out of pure chaos, making absolutely sure that every single moving part serves a distinct, unified purpose. And we've seen this philosophy echo through decades of innovation. First, revolutionizing transport with streamlined high-speed rail and the spatial genius of those folding bikes. Second, standardizing information. Think of highly legible national road signage or the early push for affordable home computing. And third, democratizing comfort through modern, accessible living designs. It all boils down to an absolute dedication to an efficient user experience. It's smart, practical engineering designed to simplify really complex problems. And today, that exact same mindset is being weaponized for national defense. Okay, let's fast forward to our present-day reality. Take the RAF Whiten Pathfinder building. On the surface, it's this physical, centralized fortress of modern intelligence. But its true power? That lies in its massive digital reach as the beating heart of the UK's contribution to the Five Eyes Alliance. It's not just a building. It's basically a highly optimized router for global security, rapidly sharing data with the US, Canada, Australia, and New Zealand. It's taking that historical British design principle of interconnected systems and scaling it up across the entire globe. So why the sudden evolution? Well, because this global network is operating under unprecedented pressure. The data shows a staggering 50% spike in hostile activity against UK defense. We're talking severe cyber attacks, espionage, and electronic warfare straight from state actors. To fight back, the UK had to unify its structures. They integrated the Defense Counterintelligence Unit, which handles counter-espionage, directly with the Military Intelligence Service. It creates this incredibly unified front, streamlining Navy, Army, Air Force, and Space Command intelligence into one cohesive, rapid response organism. But here's the harsh reality of modern conflict. Human analysts, no matter how brilliant, simply cannot parse the sheer overwhelming volume of global threat data pouring into hubs like RAF Whiten. The intelligence is quite literally only as good as the processing power behind it. To counter sophisticated, automated cyber threats, you absolutely need sophisticated, automated digital defense. We are officially transitioning from the era of the human codebreaker straight into the era of the artificial intelligence operative. And the days of looking for one single best AI, those are over. Modern defense requires hyper-specialized digital operatives. Take Gemini 3 Pro, for instance. Think of it as the versatile communicator. It scores 81% on visual benchmarks, meaning it absolutely excels at interpreting satellite feeds and situational charts. Then you have Claude Opus 4.5, the engineering specialist. Clocking in at 80.9% on complex coding benchmarks, Claude acts as your frontline software engineer, instantly patching vulnerabilities and executing complex workflows completely on the fly. But when things get really complicated, when you are dealing with deep technical challenges and high-stakes decision-making, raw reasoning power is non-negotiable. And that's where GPT 5.2 steps in as the reasoning powerhouse. We're looking at a massive generational leap here in abstract reasoning. It sits at a dominant 54.2%, vastly outperforming Claude's 37.6% and Gemini's 31.1%.
In the intelligence world, this is the operative you deploy to solve unprecedented zero-day cyber attacks where there is literally no prior playbook to go by. To really drive home just how insanely capable this reasoning engine is, consider this number: 100%. GPT 5.2 achieved a flawless, perfect score on the AME Advanced Math Examination. When you're evaluating models for high-security environments, this isn't just some neat party trick. It represents airtight mathematical logic. It means the system can orchestrate incredibly complex, multi-step defensive strategies without hallucinating or losing the plot. It's a level of digital competency that changes the entire landscape of national defense. But, of course, running these colossal, hyper-specialized AI models simultaneously across a global network creates a massive friction point. We have to take a step back and ask, what is the physical cost of all this processing power? Because we are moving out of the digital ether and crashing hard back into physical reality. Advanced AI is incredibly hungry, and it's creating a severe energy bottleneck for everyone involved. The truth is, advanced AI requires an astonishing amount of power. Just look at the thermal footprint of a modern data center, radiating intense heat. It really reveals the staggering amount of electricity needed to keep these operations running. Every single time GPT 5.2 solves an abstract puzzle or Gemini processes a visual satellite feed, it is burning through our terrestrial power grid. We are essentially running the brilliant efficiency of British engineering straight into the hard, unforgiving limits of physics. To try and tackle this computational demand, the UK is distributing the load geographically. They've networked these national innovation hotspots right across the country. You've got AI-driven discovery happening in the Oxford-Cambridge arc, Greater Manchester's intense focus on global tech innovation, all the way up to cutting-edge hardware development in Scotland. It's a brilliant distributed brain trust structured to squeeze every single ounce of utility out of every megawatt of power and maximize digital defense capabilities. But here's the real kicker. Even with all these hyper-optimized regional hubs, the math simply isn't adding up anymore. Global AI demand is experiencing roughly 100x growth. Its computational needs are exponentially outpacing our traditional terrestrial energy infrastructure. Let's be real. If national defense relies on AI and AI relies on power, then whichever nation secures the next generation of scalable energy effectively secures the future of its intelligence networks. So what's the fix? Well, the proposed solution pushes the boundaries of engineering entirely off the map. To beat this energy bottleneck, the next frontier literally involves leaving Earth. Stage 1 proposes achieving orbital scalability, deploying AI compute hardware directly into orbit for continuous, uninterrupted solar power, totally free from atmospheric interference. Stage 2 scales this up into a lunar industrial complex, using moon-based factories to build AI hardware natively in space with rocket-free launch systems. It really is the ultimate evolution of that original British design philosophy, building an optimized system where the environment perfectly matches the mechanical need. Unchaining artificial intelligence from Earth's energy constraints paves the way for a radical evolution. We are looking at the emergence of highly advanced, omnipresent digital guardians. With a limitless space-based compute power, these systems won't just analyze old data. They will predict and neutralize global security threats instantaneously, long before they ever manifest in the physical or digital worlds. It's almost sci-fi, but it's where the engineering is headed. The end game of this roadmap is absolutely staggering. We're talking about civilization-level scale, targeting a Type 2 civilization status. The goal is to capture and utilize over 100 terawatts of compute power per year directly from space. This isn't just about winning a cyber war anymore. It's about ensuring continued, unassailable technological supremacy. It's about building an intelligence apparatus so incredibly vast and so deeply integrated with the cosmos that traditional concepts of terrestrial defense basically become obsolete. Which leaves us with a truly profound question to consider. We started this explainer talking about the humble brilliance of standardizing road signs and designing folding bicycles. And now, we're looking at off-planet solar-powered AI arrays. So as we move our processing power to the stars, will human intelligence or artificial intelligence dictate the future of our security? The physical structures we build today are going to house the digital minds of tomorrow. Thanks so much for joining me for this explainer. Keep questioning, keep learning, and I'll see you next time.